Teenagers in garages, volunteer engineers in underground labs, and coders now piloting drones. These are not conventional soldiers. They are the civilian innovators and technical experts behind Ukraine's new generation of AI-enhanced kamikaze drones, assembled in secret bunkers and repurposed factories. They didn't train at military academies, yet they are building some of the deadliest weapons on the battlefield. How did they achieve this shift in modern warfare? Inside Ukraine's secret drone factories, a quiet revolution is underway. As Russia deploys record numbers of Shahed drones, Ukraine's response is changing the rules of combat. The question now: how can a low-cost drone built in a civilian garage challenge advanced Russian military equipment? A $500 drone versus a $5 million tank. How kamikaze drones are changing the rules of war. On today's battlefield, the contest between a $500 kamikaze drone and a $5 million tank is not just a mismatch. It's a fundamental reset of military economics. Kamikaze drones, also known as loitering munitions, have become the most cost-effective way to destroy high-value assets. For Ukraine, the math is simple and brutal. A single, affordable drone can wipe out a tank or armored vehicle worth millions using little more than a GPS module, a repurposed camera, and an explosive payload. This efficiency is not just a matter of saving money. It's a way to stretch limited resources while inflicting outsized damage on Russian forces. The impact of these drones goes beyond destroyed hardware. Their presence is felt deep behind enemy lines, where no place is truly secure. In one recent strike, a Ukrainian drone descended on a Russian command post miles from the front, bypassing traditional defenses and detonating with precision. The psychological effect is immediate. Russian troops know that rear areas, once considered safe, are now within reach of near-silent, low-flying threats at any hour. This constant sense of vulnerability forces Russian commanders to divert resources, relocate supply depots, and maintain a heightened state of alert, which strains morale and disrupts operations in ways that conventional artillery rarely achieves. The tactical flexibility of kamikaze drones has also changed how modern armies fight. Ukrainian units now request drones as frequently as ammunition, and in some sectors, drones outnumber artillery shells. Their roles have grown far beyond simple attack missions. Drones provide real-time intelligence, adjust artillery fire with live video feeds, and strike at precise moments to maximize disruption. Their small size and modular construction allow them to be launched from almost anywhere. Fields, forests, even the back of a pickup truck, making them unpredictable and difficult to counter. Russia's response has evolved in turn. To exhaust Ukrainian air defenses, Russian forces deploy waves of low-cost foam decoy jets, which can make up nearly half of an attack wave. These decoys force Ukrainian operators to spend precious air defense missiles and attention on non-lethal targets, increasing the odds that actual strike drones or missiles will slip through. Despite these countermeasures, the success rate of Russian drone strikes has climbed from just 6% in late 2024 to nearly 16% by June 2025, with some nights seeing almost half of all drones reaching their targets. This back and forth underscores how drones have become central to the contest for control of the air and ground. For Ukraine, the numbers are staggering. Official reports indicate that Ukrainian drones have struck over 10,000 Russian targets, from armored vehicles and artillery pieces to electronic warfare stations and logistics hubs. Each of these strikes represents not just a tactical victory, but a cumulative pressure on the Russian military's ability to sustain its operations. The sheer volume raises a critical question. How do you build enough drones to reach these numbers, especially when every day of the war demands more? The answer lies not in massive state-run factories, but in a decentralized network of civilian workshops, improvised assembly lines, and clandestine labs. Many of Ukraine's drones are assembled in garages, basements, and repurposed industrial spaces, often under threat of airstrikes. This approach allows for rapid innovation, quick adaptation to battlefield needs, and a production tempo that traditional military procurement cannot match. Civilian volunteers, engineers, and small tech firms work together to source components, design new models, and deliver finished drones to the front lines in record time. This decentralized production model is not just a necessity, it's become a strategic advantage. Ukraine's ability to mobilize its civilian tech sector, adapt designs on the fly, and maintain secrecy has allowed it to keep pace with the relentless demand for drones. The ingenuity and resilience of these teams, working far from the spotlight, have made it possible for Ukraine to sustain its drone operations even as Russian attacks target supply chains and infrastructure. As the war drags on, the need for drones only grows. Meeting this demand requires more than just technical know-how. It demands creativity, speed, and a willingness to transform ordinary spaces into centers of military innovation. The next chapter in this story takes us inside the garages and underground labs where Ukraine's drone revolution is being built, one device at a time. From garages to underground labs, inside Ukraine's secret drone factories. In Ukraine, ordinary workshops and garages have become production hubs for a new kind of warfare. The demand for drones has driven an ambitious goal: 1 million units produced annually. This rapid scale-up has relied on a network that brings together government initiatives, private tech firms such as quantum systems, and volunteer groups. These partnerships have doubled local production capacity in less than a year, enabling Ukraine to respond quickly to shifting battlefield requirements. The transformation of civilian spaces into micro-arms plants is central to this effort. Garages that once housed personal vehicles or hobby electronics are now assembly lines for Kamikaze drones. Using swap-and-go modules and on-site 3D printing, workshops can crank out a fully assembled drone in just hours. This modular approach means that if a single component fails or is damaged, it can be replaced without halting the entire process. 3D printed parts allow workshops to adapt designs quickly, responding to new challenges as they arise. The result is a manufacturing network that is flexible, decentralized, and able to sustain high output despite constant pressure. Ukraine's production model circumvents traditional bottlenecks by relying on commercial off-the-shelf parts. Civilian-grade cameras, GPS modules, and batteries are sourced from global markets and integrated into military designs. This approach reduces dependency on specialized military components, ensuring that production can continue even when supply chains are disrupted. Engineers and technicians continually adapt these components for the combat use, making technical adjustments as new requirements emerge. The process is iterative and fast-paced, with feedback from the front lines leading to immediate design changes. The production network faces persistent threats. Some facilities operate underground, shielded from aerial surveillance and missile attacks. Others relocate frequently, moving equipment and personnel after strikes to avoid detection. When a workshop is hit, new sites are established quickly, minimizing downtime. This constant adaptation is necessary for survival and has become a defining feature of Ukraine's manufacturing strategy. Much of the production effort is fueled by collaboration. Private tech companies provide expertise in electronics and robotics, refining assembly processes and introducing advanced manufacturing techniques. Volunteer groups and crowdfunding campaigns help source materials and raise funds for equipment. The Army of Drones initiative, for example, enables ordinary citizens to contribute directly to the war effort, whether by donating funds or sourcing critical technologies from abroad. This grassroots involvement ensures that even as the conflict grinds on, the flow of new drones to the front remains steady. Western defense companies have recognized the effectiveness of Ukraine's approach. By establishing partnerships with local firms, they accelerate the introduction of advanced systems and gain real-time insights into drone warfare. These collaborations allow for rapid upgrades and the integration of new technology, giving Ukraine access to capabilities that were unavailable only months before. For Western firms, the partnership is a chance to test and refine products in live combat, while for Ukraine, it is an opportunity to stay ahead of evolving Russian tactics. The workforce powering this decentralized network is diverse. Factory workers, engineers, university students, and hobbyists all contribute, often working in shifts around the clock. In some facilities, teams manually solder circuit boards and assemble airframes, tailored to specific missions. Retired specialists bring decades of experience, while younger volunteers introduce new programming and design skills. Each contributor plays a role in a system built to adapt and endure. Ukraine's distributed production model has allowed it to innovate at a pace few traditional arms manufacturers can match. By using modular construction, commercial parts, and a flexible workforce, Ukraine maintains a steady supply of drones despite ongoing attacks and supply challenges. The country's ability to adapt quickly, harness civilian expertise, and integrate new technologies has become a strategic advantage. This network does more than just produce volume. It enables Ukraine to field a range of drones with specialized capabilities. Each model is designed for a particular mission profile, reflecting the creativity and determination of those building them. The next step is to examine the drones themselves and understand how these machines are shaping the conflict on the ground and in the air. The drones leading the fight. A look at Ukraine's cutting-edge arsenal. Ukraine's drone fleet features a range of specialized systems, each designed to address a specific operational need in the conflict. The AQ-400 Scythe stands out as a prime example of scalable, cost-effective engineering. Built from milled plywood sourced from civilian furniture factories, the Scythe's airframe is assembled quickly and does not require highly skilled labor. Its wingspan measures 2.3 meters, and it weighs 100 kilograms. The Scythe can be efficiently packed. 30 fully assembled units fit into a single shipping container, streamlining logistics and deployment. It takes off using either tricycle landing gear or a catapult with rocket boosters, adapting to available launch sites. The Scythe's performance specifications reflect its role as a deep strike weapon. It carries a payload of 43 kilograms, with 32 kilograms dedicated to the warhead, supporting either thermobaric munitions or dual 122mm artillery shells. The drone's cruise speed reaches 144 km per hour, with a top speed of 200 km per hour, and it remains airborne for up to 6.5 hours. Its standard strike range is 750 kilometers, extendable to 900 kilometers with certain engine configurations, or the payload can be increased at the expense of range. Priced at $15,000 for the basic airframe and $30,000 with advanced guidance systems, the Scythe is affordable for mass deployment. Guidance relies on a laser altimeter for low-altitude flight to avoid GPS jamming, and a visual positioning system at higher altitudes uses landmarks to maintain accuracy. For moving targets, a video link allows manual control, though this increases cost and reduces range. The Scythe can be deployed in swarms using a leader-follower method, where one lead drone with navigation capability guides a group of 9 saturating target areas and complicating enemy air defenses. For short-range, high-precision attacks, Ukraine uses first-person view FPV drones. These compact devices are manually piloted, typically equipped with GoPro cameras for real-time navigation. They fly at low altitudes, often below radar thresholds, making detection and interception difficult. Operators can maneuver through complex environments, urban areas, forests, or trench networks, before delivering their payload directly to the target. One documented example involved an FPV drone skimming just above the ground to evade Russian electronic warfare, then striking an armored vehicle as it attempted to reposition. The simplicity and agility of these drones provide a tactical advantage, especially in close combat scenarios. The UCAV Punisher brings a different set of capabilities. Developed by Ukrainian veterans and supplied to the armed forces since 2019, the Punisher is designed for reconnaissance, direct action, and support. Missions behind enemy lines. With a maximum takeoff weight of 7.5 kilograms and a 2.5 kilogram payload, it can deliver precise strikes on tactical targets. The Punisher employs a modular payload system with 3 interchangeable 75mm warheads, allowing operators to select between high explosive or anti-armor munitions based on mission requirements. Its operational ceiling is 400 meters. Cruise speed is 28 meters per second, and it achieves a drop accuracy of 4 meters. Launch preparation takes just 10 minutes, enabling rapid deployment and quick repositioning after a strike. The Boba drone serves a strategic function in Ukraine's arsenal. It has been used in confirmed long-range strikes, notably targeting Moscow's business district and damaging infrastructure linked to Russian command and control. Unlike smaller drones focused on frontline targets, the Boba is engineered for deep strike missions, disrupting critical nodes in enemy logistics and communications. Its range and payload options make it suitable for both infrastructure attacks and psychological operations, extending the reach of Ukrainian forces into the heart of Russian territory. Loitering munitions such as the RAM-2 add another layer to Ukraine's drone strategy. These drones can remain airborne over contested areas, providing real-time intelligence and waiting for the optimal moment to strike. The RAM-2 has been integrated into swarm tactics, particularly in operations near Donetsk, where coordinated attacks overwhelm enemy defenses and increase the likelihood of successful strikes. Operators monitor live video feeds, ensuring that each munition is used with maximum effectiveness. The combination of loitering capability and swarm deployment enables flexible, layered assaults on both fixed and mobile targets. Each system in Ukraine's drone arsenal reflects a broader pattern: rapid innovation under the constant pressure of war. The focus on modularity, scalable production, and adaptability allows Ukraine to maintain a technological edge despite resource constraints. These drones are not just machines. They are the result of coordinated effort, technical skill, and a clear understanding of battlefield requirements. Behind every successful drone operation lies a network of individuals who design, assemble, and deploy these systems, often in challenging conditions. Their work sustains the technical backbone of Ukraine's resistance and drives ongoing adaptation on the front lines. The next layer of this story reveals the people whose ingenuity and determination turn these concepts into reality. 5. The everyday heroes, powering a nation's resistance. In Ukraine, the face of resistance is not defined by uniforms or rank, but by the steady work of ordinary citizens who have stepped into extraordinary roles. The nation's drone program draws its strength from a wide cross-section of society: civilian engineers, university students, high school trainees, and volunteers, each contributing critical skills to the war effort. These individuals work in makeshift workshops and underground labs, adapting to the demands of a conflict that leaves no room for delay. Their collective effort has created a technological backbone that sustains Ukraine's ability to respond rapidly to battlefield threats. Civilian engineers, many with backgrounds in consumer technology or robotics, have shifted their expertise to the urgent needs of defense. Their transition from commercial projects to military applications has been marked by improvisation and resourcefulness. In repurposed garages and basements, they use 3D printing to produce drone frames and components, modifying designs as battlefield requirements evolve. The pressure is unrelenting. These teams work long hours under the constant risk of missile strikes, often relocating production after attacks to maintain operational security. Each relocation is a reminder that the stakes are high and that every day lost could mean missed opportunities on the front. The workforce is diverse and adaptive. Experienced engineers work side by side with younger volunteers, including teenagers who receive technical training through government-backed programs like Brave One. In these workshops, knowledge is shared across generations. Seasoned technicians teach the basics of soldering and electronics assembly, while younger recruits bring fresh perspectives and digital skills. The result is a collaborative environment where each participant learns from the other, and where the urgency of the mission accelerates the pace of innovation. This cross-generational teamwork ensures that production continues even as threats mount and conditions shift. Brave One, launched by the Ukrainian government and supported by the Ministry of Digital Transformation and the Ministry of Defense, has emerged as a central hub for this grassroots technological mobilization. The platform connects developers, manufacturers, and military stakeholders, streamlining the process of turning promising ideas into operational systems. By October 2023, Brave One had distributed over $1 million in grants across 57 defense projects, including UAVs, ground robotics, and artificial intelligence solutions. This approach allows Ukraine to bypass traditional procurement delays, moving projects from concept to deployment in a matter of weeks. Brave One's network now encompasses nearly 1,000 companies, uniting a previously fragmented ecosystem into a focused engine of wartime innovation. Alongside institutional support, crowdfunding initiatives like the Army of Drones have enabled ordinary citizens to participate directly in the war effort. These campaigns break down the costs of drone production, inviting contributions that range from funding individual components to supporting entire manufacturing batches. The decentralized nature of this funding model reflects the realities of wartime logistics. With centralized supply chains vulnerable to disruption, a mosaic of microlabs and local donors keeps production resilient. This model transforms small acts of support into tangible assets on the battlefield, reinforcing the sense that the entire country is invested in its own defense. The risks faced by those involved are substantial. Workshops and labs operate with the understanding that they may become targets for Russian strikes, as seen in repeated attacks on production sites in Tatarstan and elsewhere. In response, teams have adopted a mobile approach, frequently relocating their operations to avoid detection and minimize downtime after an attack. This constant movement demands flexibility and discipline, but it also fosters a culture of innovation under pressure. The need to adapt quickly to changing circumstances has become an asset, driving faster iteration and the rapid integration of new technologies. Personal stories from within this movement underscore the scale and determination of the effort. Civilian programmers now develop navigation and counter-jamming algorithms for drones, drawing on skills honed in commercial tech. Teenagers, some still in school, assemble circuit boards and calibrate sensors, describing their work as both a responsibility and a source of hope. Across workshops, individuals who once pursued careers in unrelated fields have found new purpose in supporting the nation's defense. Their contributions, though often unrecognized outside their immediate circles, are essential to sustaining Ukraine's technological edge. What emerges from this mosaic of effort is a defense industry unlike any other, one defined by its grassroots origins, its adaptability, and its capacity to mobilize talent from every corner of society. Every assembled drone, every successful deployment, is a reflection of collective resolve. In Ukraine, the boundaries between civilian and military innovation have blurred, creating a model of resistance that relies as much on ingenuity and community as on firepower. As Ukraine's drone program continues to evolve, its impact is felt far beyond the country's borders. The integration of civilian expertise, rapid adaptation to battlefield needs, and decentralized production are not just shaping the outcome of the current conflict. They are setting new precedents for how nations might defend themselves in the future. The world is watching as these everyday heroes redefine what it means to fight for survival with technology and determination. Ukraine's drones have become a catalyst for change in military doctrine. By using affordable, rapidly produced technology, the conflict demonstrates how decentralized innovation can counter even the largest arsenals. Western defense leaders warn this could rewrite global military procurement, as the world's armed forces study Ukraine's methods for lessons on weapons, tactics, and training. This is more than a regional conflict. It is a signal to governments worldwide. In a world where a $500 drone can reshape a battlefield, are governments ready to adapt? If you found this inside look revealing, subscribe for the next deep dive into modern warfare's biggest shifts.